Lesson 12.8 is finding the exact value of trig functions when they're in degrees. So this unit circle, talked about a little bit, is always going to have a radius of 1. And so this point right here would be the point you're going right 1, not up or down, so it'd be 1, 0. This point here would be not going right or left, but up 1, so it'd be 0, 1. And then this point back here would be going back 1, so -1, 0. And then this point down here would be going 0, -1. That's going to be important when we do number 1, 2, and 3. These are all called the quadrantal angles. Quadrantal angles. That means that I just spelled quadrangle. Quadrantal. Why did I do that? Quadrantal. Sorry. So what we need to think about too when we're doing unit circle stuff is the special right triangles, the 30, 60, 90s, the 45, 45, 90s. And then this is the same, just 60, 30, 90. And that's being formed from making these reference triangles. So let's say I have an angle that is making a 30 degrees right here. That would look like this, where this is my 90 in the corner. That means this angle must be a 60, so hopefully you're with me. Well, this is my hypotenuse, or really the radius, which I told you in these problems, the radius or the hypotenuse is always 1. 1, 1, 1. So we got to think about what is the relationship between the short leg and the hypotenuse. Do you remember that this is 2 times the short leg, and then you would solve that? So I would take 1 divided by 2. That means this is a half. This is half of this, right? And then to get the longer leg, it's always the leg times a square root of 3. Well, this is my L, so I would have 1/2 times square root of 3, which is really square root of 3 over 2. That's the long leg. And I want to talk about something too. A half as a decimal is 0.5, and then square root of 3 divided by 2 is actually like a 0.87, almost a 0.9. So you can see how this length is really a longer or bigger number than the short leg. So remember these two things. All right, in the 45, 45, 90, remember that these are your legs, and then the hypotenuse is leg times the square root of 2. So if I solve that, I would have to divide by square root of 2. Can't leave it like that. I'd rationalize the denominator, and that gets square root of 2 over 2. And it's an isosceles triangle where both legs will be the same. Just so you know that square root of 2 divided by 2, that's about a 0.7 inches, feet, whatever we're dealing with. And then the 30, 60, 90 is easy because we already did it right here. So the short leg is across from the smallest angle, the 30. We said this is always a half. Across from the bigger angle, the 60, this is always square root of 3 over 2. You've got to get where you memorize all these values. Okay, so now let's put it into action. It says, given the following unit circle, rotate the green dot to the appropriate angle and then find the exact value of the function. So you're going to have to take this green dot on Delta Math, rotate it 180 degrees. When you have a quadrantal angle, you're just thinking of the ordered pair here. So we said this would be -1, 0. Sine is the y value, or the second number, or the height. So that would be simply 0. If they would have wanted cosine there, that would have been the x value, -1. Cosine of 90, take the point, drag it to where it's 90 degrees. Again, since this is on one of the axes, think of the ordered pair here. This is 0, 1. Cosine is the x value, so it'd be 0. Tangent of 270, think about that's down here. That ordered pair is 0, -1. Tangent's a little harder because it's y being divided by x. So we would take -1 divided by 0. You can't divide by 0, so that's called undefined. Also think about it as a vertical line, which has undefined slope. If it would have been this point, then you would have had 0 divided by 1, which is 0, which is a horizontal line, has 0 slope. So vertical line's undefined here and here. Horizontal would be 0. Okay, so then we get to sine of 330. That does not fall on a y-axis. 330, think about where that would be. We'd be all the way around here-ish. 330 degrees. How far away are we from a 360? We're 30. That's called my reference angle. That's why we've worked on this. So I'm really using this shaped triangle to do the math here. They want sine of 330. So they want the opposite leg, the y value. The y value here would be the short leg. What is the short leg every time? What do we say it equaled? A half. So this is just 1/2. But since we're down here in quadrant 4, the y value, the height, would be a negative. Cosine of -45. When you have a negative angle, instead of opening counterclockwise, you open clockwise. So we're going to go halfway between quadrant 4 and create a triangle like this. Here's my reference angle, is 45. And so I'm using the shape triangle, the 45, 45, 90. They're wanting cosine, which is the adjacent leg. The adjacent, which either way the legs are the same, it's a square root of 2 over 2. Cosine in quadrant 4, it's a positive x, so it's positive. And then we got tangent of 240, that would be in here. Makes my triangle here. So if this is a 240 degree turn, 240 minus 180 means this is really a 60 degree angle. So I'm looking at the 60 degree triangle. They want to know tangent, which is y over x. The y, the long leg, over the short leg. This long leg is square root of 3 over 2 divided by the adjacent, which is a half. I can't divide fractions, instead I need to multiply by this reciprocal. Multiply straight across, you get square root of 3 over 1, which is simply square root of 3. Tangent in quadrant 3 is positive because we took a negative divided by a negative.